Hello everyone, this video is a tutorial for setting up the Lightware Crestron Home driver, specifically for the Taurus UCX series from Lightware. This is a powerful line of AV switchers that is now natively supported within the Crestron Home environment. So let's start from the beginning. First, open the Crestron Home setup application and navigate to the room where you want to add the driver. In our case, we are selecting the dining room. Then go to the root folder called Drivers, open the Platform section, and locate Lightware. Inside that folder, you will see the driver named Taurus UCX series. Click the plus icon and assign a descriptive name to it. Since this driver communicates over the TCP protocol, you need to enter the IP address of the device, while the IP port should remain set to 6107. On the next screen, you will need to decide how many serial extensions you want to use. This refers to the RS232 serial ports on the Lightware device. Each of them allows you to configure up to 10 commands, which we will explain later. For now, we will add 2 extensions, because the device we are testing has 2 serial ports and we want to use both. If 10 commands per port are not enough, you can always add more extensions since they will not affect the driver's functionality. After that, you will need to enter the license key that you previously purchased and generated on our website. More information about purchasing and generating the license can be found in the video link in the description. With that step completed, we have added the platform driver to the room. It automatically generates all the necessary extensions, which we will now go through one by one. Let's go back to the root folder and open the Manage Platforms section. Here we can see that 13 extensions have been generated. The first extension we will use is the AV switcher, so we add it now. In this step, we need to select how many audio, video, and USB inputs and outputs we have. This is important because the driver is designed to support the entire UCX series, and we need to tailor it to match our specific device. If the number of inputs and outputs is entered incorrectly, the driver may not function as expected. Now let's see the driver in action. We can observe that it provides full functionality for video, audio, and USB switching. Additionally, within the app, we can define whether the audio or USB should follow a specific video output. Here we can also see that the number of inputs and outputs matches the values we selected earlier, so it is important to ensure they accurately reflect the real setup. The next thing we will add is the CEC remote control, which sends commands through one of the video outputs. It is important to select the correct HDMI output, because the command is sent only to that specific output and not all of them. In the web browser, by accessing the device's IP address, we can see that the HDMI output has CEC control, which we have replicated with the same functionality inside the Crestron Home application. Keep in mind that this remote uses standard generic CEC commands, which can be found in the user manuals. Here is what it looks like inside the Crestron Home application. Next, we will add the GPIO extensions, one as an output and the other as an input. First, we will add GPIO number 1 and explicitly set it as an output. In the following step, we can choose which icons and labels will appear depending on the state. In this example, we selected settings that represent controlling lights with this output, which you can now see demonstrated in the app. We will now configure GPIO port 4 as an input. Since inputs do not have a user interface element in the app, we can skip the next screen, which is intended for output configuration. This input can be used within the Actions and Events page, where it serves as a trigger that performs an action when activated. In our case, we will set it up so that every time the input goes high, it toggles the output we previously defined. Of course, we can use this input to trigger any other action that is not related to Lightware. We also have a port for an occupancy sensor, and in this example, we will use it to send a push notification when the room becomes unoccupied. We will select the active high type for this sensor. After adding the extension, we go to the Actions and Events section where we locate the sensor extension and use the free event to trigger a pushover action that sends a push notification. Here you can see this configuration in action. The final extension we will add is used to send serial hex commands through one of the serial ports on the Lightware device, depending on the model. In this example, we will use output 1 and send generic commands. Once again, it is important to note that hex commands must be written in octets and separated by spaces. For this demonstration, we will create quick action buttons in the Actions and Events section to trigger the sending of these commands. However, you can use any type of trigger to activate them. In this example, you can see that by pressing the Quick Actions button, we receive the expected message on the remote device connected to the serial port of the Lightware. And with that, this basic tutorial is complete. Now it's up to you to explore all the possibilities of this driver, discover the full range of available triggers and actions, and test it in your projects using the free trial license. If you have an idea for improving the application, feel free to contact us, and we will provide you with the latest version in the shortest possible time. That's it for now. See you in the next video.